Hello guys, thanks for watching my video. Today we would like to prove the Euler-Mascheroni constant, okay? And it's in by Euler, okay? This is the Euler-Mascheroni constant is equal to the sum from k equal to 1 to infinity 1 over k minus log of 1 plus 1 over k, okay? So this is what Euler so it, okay? So actually the definition of this Euler-Mascheroni constant, okay, is nothing but the limiting value of harmonic number minus natural log of n, okay, right? So this is the actual definition, but Euler shows that this sum, okay, also approaches the Euler-Mascheroni constant, okay. What we did in the earlier, so we are going to prove in that way, okay. Now we know that log of 1 plus x is x minus x squared by 2 plus x cubed by 3 minus x 4 by 4 plus and so on, okay. This is natural log, okay. And you can see the proof for this one, okay. So implies now this log transfer on the right hand side and all this on the left hand side and extend them, so you get x minus log 1 plus x is x squared by 2 minus x cubed by 3 plus x 4 by 4 minus x 5 by 5 and so on. Now putting x equal to 1, 1 by 2, 1 by 3 and so on up to 1 by n, successfully we have, if you put 1, so 1 is minus log 1 plus 1, okay, is equal to 1 squared by 2 minus 1 cubed by 3 plus 1 fourth by 4 minus and so on, okay. Now putting x equal to 1 by 2, so 1 by 2 minus log 1 plus 1 by 2, which is equal to 1 by 2 into 1 over 2 square minus 1 over by 3 into 1 over 2 cube plus 1 by 4 into 1 over 2 to the 4 minus 1 by 5 into 1 over 2 to the power 5 plus and so on. So 1 by 3, x equal to 1 by 3, so 1 by 3 minus log 1 plus 1 by 3, which is equal to 1 by 2 times 1 by 3 square minus 1 by 3 times 1 over 3 cube plus 1 over 4 minus 1 over 3 to the 4 minus and so on, okay. And continuing this way up to n times 1 over n minus log of 1 plus 1 over n is equal to 1 by 2 into 1 over n square minus 1 over 3 into 1 over n cube plus and so on, okay. So adding column wise, meaning add like this, okay, add in this way, then what do you get? Yeah, you get that 1 plus 1 by 2, 1 by 3 and so on up to 1 over n, and this one also adding them, then you get 1 plus half plus 1/3 plus and so on up to 1 over n minus log 2 plus log 3 by 2 plus log 4 by 3 plus and so on up to log n plus 1 by n, right? Which is equal to here, you will see here 1 by 2, 1 by 2 all are common, okay. 1 by 2, 1 by 2 common, so taking out 1 by 2 you get 1 over 1 square plus 1 over 2 square plus 1 over 3 square and so on up to 1 over n square minus, and similarly 1/3, okay, 1/3 is also there common, so therefore you get minus 1 over 3, 1 over 1 cube plus 1 over 2 cube plus and so on, okay, up to 1 over n cube. And here also if you see here 1 over 4, okay, 1 by 4 is common here, right, 1/5 also common here. So doing in that way, now this one is nothing but when this x equal to 1, so log is also 2, right? When x equal to half, log is 1 plus 1, 1, 2, right? So seeing this pattern, okay, when meaning when k is equal to 1, so this one, right? So when k is equal to half and when k equal to 1/3, this 1/3, right? So therefore the sum from k equal to 1 to n, 1 over k minus log of 1 plus 1 over k. If you put k equal to 1, so 1 is this one minus, if you put here k equal to 1, so log of 1 plus 1, here you get this one, right? And when k equal to 2 and so on, right, which is equal to 1 2 of this one. Okay, now taking limit as n approaches infinity. Okay, we have that for the left hand side you get k equal to 1 to infinity of 1 over k minus log of 1 plus 1 over k. Here this when n tends to infinity, so this will be nothing but the Riemann zeta function evaluated at 2. Okay, zeta 2 by 2 minus zeta 3 by 3 and plus and so on. Okay, and therefore sum from k equal to 1 to infinity 1 over k minus log of 1 plus 1 over k is nothing but Euler-Mascheroni constant. Okay, this one if you calculate, if you put the value of zeta 2 zeta 3 and so on, then this will approaches or Euler-Mascheroni constant. Okay, therefore we prove that what we are desire. Okay, or sum from k equal to 1 to infinity 1 over k minus log of 1 plus 1 over k is the Euler-Mascheroni constant, and this one if you see it sum we will start from k equal to 2 to infinity of zeta k by k, and here is alternating, so you have to keep negative 1 to the k. Okay, when k is equal to 2, so this will be zeta 2 by 2. When k is equal to 3, negative zeta 3 by 3. So this will be okay. Our main focus is this one. Okay, but our definition of the Euler-Mascheroni constant is nothing but okay, this is the original definition of this, the Euler-Mascheroni constant. So the Euler-Mascheroni constant is nothing but limiting value as limit as n approaches infinity of this harmonic number minus natural log of n. Okay, but Euler shows that this summation, okay, this infinite sum from k equal to 1 to infinity 1 over k minus log of 1 plus 1 over k is also approaches this Euler-Mascheroni constant. Okay, so that will be our main focus. Okay, hence proof.